Welcome, y'all. Back to some more geometry funness. Today we are talking about angles of elevation and depression. Now, not the same kind of depression that we all like to sing about and talk about, but a different kind of depression. So, angles of elevation and angles of depression is just a way to tell you where the angle is coming from. Where does the angle start? Now, as you can read right here, both angles start at a horizontal line from the person who is observing. So, if you're doing angle elevation, for example, here we have a man on the ground whose horizontal eyesight goes across, and he's looking up towards the balloon. That's an angle of elevation because he's having to look up to something. There's an angle that's formed with horizontal to the ground to this point of where he's looking at. Now, angle of depression starts when, again, a horizontal line and the person somewhere above looking downwards towards something. Now, as you can see, these are both horizontal lines. So we're going to extend the value of this line outwards this way, extend the value outwards this way. What is the value or relation of this angle of depression and this angle of elevation towards each other? Well, if we have parallel lines, then we have two parallel lines. We have horizontal lines, two parallel lines. We have a transversal. These two angles will be considered alternate interior angles. So they will be congruent to each other. They will equal each other. So if you know an angle of elevation, you know where else it could exist. And if you know an angle of depression, you know where else that could exist. All right, so let's kind of do two examples. We do one of each. So we're going to start with angle of elevation here. So as Odysseus, my boy from the book The Odyssey, sailing back from the Trojan War, he was hit by a storm. Clouds everywhere, wind everywhere. I shouldn't that space better clear it up. Anyways, then his boat got a leak, and he knows because he probably had to repair this 1,000 times that he maybe has at the most 100 feet he could travel before his boat sinks. Now he knows that this lighthouse right here is 250 feet tall, and he does know that his angle of elevation is 48 degrees. Will he make it to land? Well, let's see. So again, as I wrote right here, there's three numbers: how far he can travel, how tall the tree is, and his angle of elevation from him to the lighthouse. So let's kind of put those in there. So we are trying to figure out how far is it from here to here. Because if we can travel so far that way, if this is less than 100 feet, then we'll be golden. Okay. Angle of elevation is from his vision, the observer, up to the top of the lighthouse. So this is where our 48 degrees exists right here. And of course, the lighthouse is 250 feet tall. So this is what we're looking for. So since this is our angle of reference, I'm going to put a theta here so we know this is what we're used for. This right here, the 250, the lighthouse was considered our opposite side, and the x would be considered our adjacent side, the side that's right next to. So which trig function uses opposite and adjacent? So in case we forgot from the last video, our little thing is some old hippie caught another hippie tripping on acid. So which one of these has an O and an A? Well, our tangent ratio. Our tangent ratio is opposite over adjacent. So using a reference angle, we'll say tangent of 48 degrees is equal to the opposite side, 250, over our adjacent side, which should be our x here. All right, so we have something set up. Let's see what we can do. So first things first, what's we got to take care of first? Why you think of that? I'm going to pick a color. Let's go with, it's red. Yeah, the x. We cannot have an x in a denominator. So what we are going to do is we multiply both sides by that x to take it out of the denominator and bring it up to the numerator. They cancel each other out. So now we're left with x times tangent of 48 degrees equals 250. Now that we have our x numerator, there's another thing we got to do with our x. We have to isolate it. We have to get it by ourselves. So we're going to divide both sides by tangent of 48. Many of you guys in class were trying to do the inverse tangent, but understand we only do inverse tangent when we are trying to find the value of an angle. We're trying to do an angle. So it cancels out over here. So that means our x is equal to whatever 250 250, not 250 degrees, 250 divided by the tangent of 48. So then we'll put that in our calculator. We have a calculator that should fit in just like that, 250 divided by the tangent of 48. For my friends out there that only use their iPhone or some online computer that makes the X kind of weird, you will put it in backwards. You'll do 250. So that part should be the same. Then divided by, but then you'll put 48, hit the tangent button, tan, and then the equals button. When you do so, you are left with 225.101. So this is 225.101 feet. If that is the case, will Odysseus make it to land before his boat sinks? The answer is no, he will not make it to land. Okay, so all the angle elevation is doing is just giving you a reference to where our angle is at. The other information also matters as far as numerical value, and then knowing our trig functions. Which trigonometry functions are we using? Let's do one more. So on our next one, we have a rescue crew. They are such a rescue crew that goes out and flies to help scenes of boat crashes. Now they cannot get too close, because if they get too close, the force of the airplane or the helicopter will blow the person down and out farther away, and it possibly underwater could drown them. Now, if the angle of depression is 42 degrees and they are cruising at roughly an altitude of 18 feet, how far does the rescuer have to swim to reach the victim? Here is our good old rescue. Put his little Red Cross shirt on. Red Cross, good job. This is our drowning victim, very desperate for help. Now, like we said, angle of depression is from the horizontal viewer, so across, downwards to where then he has a direct connection towards our object, in this case, the victim. This is where our 42 degrees exists. Now, we also have an 18 feet altitude. So that's the altitude right here. 18 feet is perpendicular altitude. So this comes perpendicular to the wall. Now, like we said earlier, where there's an angle of depression, that same angle of depression exists at the angle of elevation. So in this case, if we're doing angle of elevation, we're talking about from the victim's horizontal upwards. So that means this is also 42 degrees, which is good to know. But more importantly, what are we looking for? We're looking for how far he has swum. So this is the value we're looking for. Now, one other thing we didn't mention, now that we have this, is that this horizontal line and this altitude together makes a perpendicular corner right here. So if this is 42 degrees, that makes this 48 when you subtract it. Now, you have two options. You have these first options. We're going to put a theta right here, our first option. No, not theta, because that's what we're going to use. We're going to put an alpha sign. An alpha meaning this is our first option. We can use this as our reference angle and do opposite over adjacent, which is a tangent ratio. So we're going to be using a tangent that way. But then we get 18 over x. Again, we have another problem where we have the x in the denominator. Or we can use this reference angle up here, call that our beta right there, where we have a opposite over adjacent, another tangent, but then the x in the numerator. Either problem you do will be right, but why not make it easier on ourselves and put the unknown on top? So let's use this as our theta. This is our reference angle, this 48. So we'll say tangent of 48 equals our opposite side, x, over our adjacent side, 18. So from here on out, we're going to multiply both sides by 18 to solve for x, to isolate x by itself. This crosses out, leaving us 18 times tangent of 48 equals our x. So this is what's going in our calculator, just like that. So you take 18 times, hit tangent 48, close your parentheses, and hit enter. You should get x to equal roughly 19.991 feet, or if we round into the nearest foot, that'd be 20 feet. Hopefully that helps you guys that missed class, and also just helps you. They had to come back and review everything again. Again, if you're still having problems, let me know next time we see each other. Y'all have a wonderful day. Bye.